Our next speaker is Jens Lausten from the International Energy Agency. Jens, up to you.
I'm happy that Stephen even didn't mention where we met, because that was in a bar in Warsaw. So international working is sometimes very hard work. I'm here today to try to give a big picture. That was what I was asked to do. And I said, what better big picture can I give than try to tell you people why you are so important and why this issue is so important. It's not about you earning money, which is of course important for everyone, but it is about saving our planet. And I will try to tell you why. So I try to put this whole work, your work, into a global perspective. If I can find the right button, then here. My presentation will try to cover quite a lot of things. It would say energy efficiency in a global climate perspective. It would talk about the 25 recommendations which we made in IEA and got endorsed by presidents, including the US president at the time, George Bush. We would tell you why concepts is the answer to the question, how do we save energy? Then I would talk a little about the future. I already preempted that by using 2015 as the date on my slides, so that's quite far in the future, but I would talk about a near future where buildings should use no energy. I would talk about policy pathways, and I would talk about sustainable buildings network, and 4 times better buildings, and in the end, the role of energy performance certification. A lot of things to talk about, but luckily I have a second slot later at 1:30, where I would talk more in details about the certification and the Sustainable Buildings Network, so I will cover that very briefly here. My first point is that energy efficient buildings is very critical for a sustainable future. Buildings can deliver very large CO2 reductions at low costs, so they are the answer to the climate negotiations. What the world needs and what they agreed on in Copenhagen 1.5 years ago nearly is that we should limit climate change to around 2 degrees. Easy said, more difficult done. It means that energy consumption should peak in very, very few years from now. 3, 4, 5 years, then it should start going down. And that we should reduce energy consumption maybe around 50% or even more in 2050. Is this what is on the way? Here I took the IEA statistics and the predictions for the future, even with the economic crisis. It shows that energy would be growing and growing and growing and growing. And unfortunately, it's not biomass and renewable energy which is growing very fast. It's the use of coal and even on oil. So this is the wrong way. We are going the wrong way in the future. Compare that to our wish to peak in a very few years. It's not looking like this will happen. We tried in IEA to look at this reference scenario. Then we said, if we want to have the 2 degrees change, it's still dramatic, but it's better than 6 degrees change, I think. What do we need to do? This is the scenario we need to develop. How can we do that in a cost-efficient way? They found in this study that energy efficiency must deliver more than half of this. And even in the end use of energy, it must be more than half of the reductions that must come out of energy efficiency, at least when we talk on shorter terms. Renewable energy is another important issue. They need to deliver 1/5 of the savings. So if you put that together, you will find that nearly 75% of the solution of our climate problems must come out of energy efficiency, use of renewable energy, and that's where you come in, gentlemen. Even if we use nuclear power, if we use carbon sequestration and all the other options we can do, they can only deliver very little of this cake. So if we don't get energy efficiency, you might forget about limiting climate change. You can say, why is this the case? And it is because many different studies. I just grabbed two here. There is the IEA Energy Technology Perspectives, which comes out every 2 years. And it shows that down in the low-cost options, it's very often end-use efficiency. In the options that doesn't cost so much, you find all the renewable energy sources coming in. And if you want to do CCS or you want to do real transportation alternative, that becomes very expensive. So why pay a lot for something you can get for free, or you can even be paid for doing, is the case here. Other studies show the same. I took the McKinsey studies, the global McKinsey studies, again showing that buildings are down in the area where it's negative cost for the society. Very often also negative cost for the individual consumers. In average, there is a problem by the renter, the owner, and all this stuff, and you all know that story. And renewable energy is among the options which are not that expensive to implement. So savings in buildings might be able to pay for the solar systems. That's a way you can translate it here. You can say many other studies show exactly the same trends. And nearly all of them, they have the same mistake. They look at individual parts of the building. They look at renewable energy alone. If they looked more holistic, the picture would even be nicer. They would even be better. You can save even more in buildings if you do it in a holistic way. You can ask the question, is this really possible? And I just took one slide. I just added it this morning just to show you this is really possible. If we look at the trends in IEA countries since 1973, where we had the oil crisis, the first of them, and we started doing energy efficiency policies. We studied that and we come to the conclusion that the energy consumption today would have been 57, or in 2004 would have been 57% higher. Today it's 62, 63% higher if we had not made energy savings in those countries, in the OECD countries. This means that already today we can say that energy efficiency is the largest fuel that we use in IEA countries. We use that fuel more than we use oil, more than we use gas, because the contribution of those savings are larger than the total global oil consumption today. The savings have given us more. So the conclusion, when I conclude on this first part on the potentials, there are an extremely large potential for energy efficiency. It's very compelling, it's cost efficient, but there are many barriers which hamper this. It's not moving. People don't know about energy efficiency. They don't know about what they have to do, and that's where Resnet and other people come in. Energy performance of buildings is very important when you want to realize exactly this kind of savings, because if you look holistic at the buildings, you can choose the cheap options instead of choosing the most expensive options. So if you limit the performance of buildings, you can let it be up to the market, the individual persons, to find the most optimum way to do this. This is a thing which never have been really included in those global estimations before. So they overestimate costs and they underestimate the potentials that you can really go. But I would say we need to go even further, because on long term, buildings should not use energy. That was already stressed in Eduardo Maldonado's presentation, saying that in Europe they already decided that at least new buildings should come very close to zero energy in 2020. I know that some states here in US have done the same. California and other states have decided we want to go that way to reduce energy consumption, first of all in new buildings. One of my first tasks in IEA when I came there 5 years ago was to try to develop recommendations for the big G8 countries, including US, Canada, Germany, England, Japan, and Russia. We came up with 25 recommendations for energy efficiency. And I showed you just the list of the things here. There are, of course, much more detail there. I would show you 3 of them in the full version after this slide. But I want you to see here that 5 of these recommendations are on buildings. They say building codes for new buildings, requiring that. I come back to it. They say passive energy houses and zero energy buildings. That's something that countries should encourage. They say that every country should make a policy package for existing buildings. I don't come in more detail with that today, but certification, demands by refurbishment and things like that is an important part of this package. They also mention, which should be interesting in this group, that building performance certification should be something that every country would do mandatory. So I would show you that recommendation in details. Finally, it comes with a recommendation on doing policies to promote energy efficient windows, because that's an area where you can do a lot both in existing and in new buildings by driving the market in the right way. But on top of those 5 recommendations, you would see that there are 4 which address appliances, there are 2 which address lighting, there is 1 which address utilities, which highly also encourage that policies are put in place where utilities help people to save energy in their houses. There are overall cross-sectoral recommendations. Some of them are on finance, on putting in structures, and they all address buildings very much. So more than half of the 25 recommendations are in fact addressing the way we use energy in our buildings. This is a very important part. Let's take a couple of examples on those building recommendations. The first one was set on building codes for new buildings. It's requiring all states to have mandatory building codes. There are still a lot of states out there that countries that don't have building codes, and I hear there are a few states here in the US who hasn't mandatory building codes so far. It's a little more than a handful. Those who have building codes, they should urgently set and enforce and strengthen these building codes so that you get more bang for the buck. Is that what you say here? That you get more value for your money, you get more impact of what you're doing. We encourage here countries to do that based on at least a 30 years lifetime circle, as it was stressed also in some of the earlier presentations, that you should not look at buildings as something like you look at a refrigerator or something like that, that you buy and you throw it out some years later. Building might rest for 100 years, so why look at 7 years payback time when you buy a building? Unfortunately, many countries do that when they make building codes. So here we request them to use life cycle view and put in all the things that pay over lifetime of the building. That should be 0 in the end for the people living there. We also made a recommendation on passive design buildings. Buildings which actually use no energy, net zero energy building, or what you would call that kind of building. Could be standalone zero energy building or zero carbon buildings, it's called around in the world. That all countries should encourage that at least some people build that way, and you can demonstrate that it's possible to build it today, and they should aim at making them available on the market, even if they're more expensive than ordinary buildings. Why not try to see if you can get consumers to buy them anyway? So every country should have policies around that, and they should use this kind of buildings as the target for building codes in the future. So one day, every new building would be a 0 or a plus energy building when you build it. Those were endorsed in Heiligendamm in 2007, and George Bush was there, and after some discussion he agreed that they were good, those recommendations. So they were endorsed by state leaders from the 8 largest economies, and afterwards they were supported by India and China and other of the developing world, and the European Commission was of course there. We had the year after, we went to Hokkaido in Japan, and we came up with 2 recommendations, and one of them for buildings, and one of them says that all countries should make energy efficiency more visible in buildings. People have no clue what the use of energy in the buildings. They have no clue when they buy a building what is the energy efficiency. You can't buy a sausage without knowing how much energy this will give to your body when you eat it, but you can buy a house without knowing how much energy this house is using. It seems strange to me. So we say all countries should ensure that this is in place, and this should be through mandatory certification schemes where buyers and renters of buildings would know what is the energy efficiency in this building compared to other buildings. That's, again, Resnet should know what this is all about. They should also make structures that help people get advice on how to save energy, and that can be utilities or other areas where we can help people to get a knowledge about this. Then they have a chance to react, at least. Again, they were endorsed. It was nearly the same president who went there. They went to Hokkaido. They endorsed these recommendations, and that was when we arrived at 25 recommendations. And all the countries promised we will do a specific effort to try to implement those 25 recommendations as good as we can. We checked them later, and we found out that it was not going that well. I will talk a little more about that in my session later this afternoon, but no country even came close to having implemented all our 25 recommendations. The best one was about 68%, which were implemented or nearly implemented. Some countries, they came out with 10% which were proper implemented, and a few extra percent which were nearly implemented. So that was very bad. I would like to say here, I would move over to talk about concepts and saying when you look holistically at things, you get much further than when you look at the roof alone, when you look at the windows alone, when you look at the air conditioning system alone. Again, this should be obvious for you as Resnet people. The first example I took is the Passivhaus. I think it was one of the first examples that really promoted this vision, and that has a quite big uptake in a global scale. In some countries we talk around 20,000 buildings of that type constructed. And even if it's Passivhaus, it can also be a multiple residential building. Here the idea in Central Europe would be that if you get your energy consumption low enough, you can save your whole heating installation in the building and only use the ventilation system to heat your building. And that way you get a saving, and that's why the curve is dropping. So Passivhaus might be cheaper even at the time of investment compared to a traditional building. So you save money when you buy, and you save money every year in the future. It seems like a good business to me. The second concept I would stress here is the zero energy buildings. This is also something which today is taking up. 5 years ago, we didn't see that many examples, and now we start seeing them on all continents around in the world. I took an example from Singapore, a zero carbon building from UK, and a plus energy house in Germany that would get a score minus 15 or something like that in the Hertz index. So it goes on the other side of the zero. One of the concepts which really drive all this is the idea of intelligent design, that you consider energy already when you turn your building the right way according to the sun. Here just an example from Cairo, where you see the building from 2 angles which are very close on the lower photo, and it shows you that from the angle where the sun is coming, you have no windows. 15 degrees away from that angle, you have the windows. And that way, you never get direct sunlight in this part of the building. And that way, you reduce more than half of, or 60% of your heating load, which come from heating by the sun. It's easy in Cairo because the sun is nearly passing over the building every day. The other one is that we shouldn't forget the existing buildings. I have here a concept saying deep renovation, where this is an example on a building which is aiming at a reduction with 90% of the consumption. That's why they call them a factor 10 renovation. And as you can see, the building not even got nicer to look at, but if you took a thermal photography of it, you would see it's a totally different building. And you see a little green down in the end. It is not because they forgot insulation, it's because it's the next building in the street. So you can just see it's true that the photo is taken with the same values. I didn't mention that we also start now, which is really the front end of renovations, to see renovations that achieve a blank zero. And those examples are very few. There are, however, some of them which are not that costly when it comes to the end, because they do it when they do such a major renovation where most of the outer shell is anyway improved, and therefore they can come in with higher energy efficiency. One of my projects have been writing a book which I call 4 Times Better Buildings, aiming at showing that buildings could, in average, on a global level, reduce energy consumption with 75%. That means some of them needs to pass the zero to wage out some of the buildings that you can't improve, because you can't improve the Louvre Museum in Paris or other national protected buildings, or buildings. There might be some cases where it's very expensive to do it, and it will ruining our historic culture. If we look at zero energy buildings, I claim that on long term buildings should use no energy, but there is more in it to that, because what is a zero energy building? When I look around in the world, if I find 10 experts, I will get at least 8 different definitions of zero energy buildings. There might be even more than 10 because they can't agree with themselves. My first shot would be to say a net zero energy building is a building that provide a normal indoor comfort, because if you drop the indoor comfort, it's easy to make zero energy. You just kick away all the supply systems. And that it produces as much energy by renewable energy as it uses in losses. But just to stress that this is still complicated, because what are the comfort criteria? Do you need 20 degrees, 17 degrees, 23 degrees inside? It has a major impact on your energy consumption. What do you include in the consumption? Heating, cooling, ventilation, dehumidification, appliances, devices, our cell phones when we recharge them, our TVs. How far do you go in your zero? You can also say what are accepted productions. Is it only the stuff that's installed on top of the building? Or can you have a windmill in the garden or on the other side of the community? Or how far can you go away with your offset of your sources? How much can you use the grid? Is it okay that you export energy at any time and you get it back at any time? Or should you export at peak load and get it back at low load to be allowed to do this? Or what are the kind of storage that you need? You can drag up many, many definitions, and I hear that the European Union has a nice work ahead of them trying to define what do we really mean with this and what is even cost optimal when you do it. Just to show it in a graph, what happens if you say the first zero buildings claim zero energy, they were typically only looking at heating. So they said we had a balance on heating, so we have a zero energy building. The next one said you should probably include cooling, and in particular when you did them here in Florida, that could be a very important thing. And then you put, what about the lighting system? And you can take all the appliances in the kitchen, the washing machine and all this stuff, and you could say total energy consumption, and then you could in the end claim we want them off grid. So then we're sure they're not using any energy at any time. You could have zero carbon buildings, which is again dragging down the cost a little, but in general, the more you include, the more strict you are, the more costly those buildings are. So remember that when you discuss zero energy buildings, when somebody say, we can do it very cheap, ask them where on a line like that they are, because that's very important for the comparison. Again, a conclusion here. When looked at the present costs, it is definitely clear that you have to go over the passive design before you install the solar systems. There are some bad examples where they installed a lot of PV systems and they came out, it would cost you $100,000 to go there. If they had gone the other way around, it would have cost $5,000. The consumption needs to be based on renewable energy. Use of concepts is a way to drive it down. Then you can learn from other people's experience and you can develop concepts where the industry can produce exactly the things that you need in your building. If every single building is treated different, it's difficult for the industry to follow you. I see two ways to go to the zero energy. We can take the normal learning curve, which you have everywhere. You start with a few demonstration projects and you end up with having the full market of this technology. You would probably use policies to help somebody to make a demonstration project. You pay them a lot of money to go there. Then you try to upscale that and make more demonstration projects at lower costs. Then you make general schemes that support the people to do this kind of projects. And then you do a lot of general incentives in the market, and certification is definitely one of the important tools, and it's important that you get benefits when you do this kind, when you can resell it more expensive. Then you come to a point where this can come into your building codes, and finally, building codes are not doing it alone. You need to enforce them, otherwise you don't get 100% compliance. This could be the story about many things in energy efficiency. Zero energy, low energy buildings, a special technology could be low energy windows or other things. You can drive them first by showing that this is possible and then upscaling slowly. There is another way which was stressed also in Maldonado's presentation where some countries say we want to have zero energy building codes in some years from now. Denmark, Germany, Netherlands, France, UK have all done those kind of decisions before the European Union decided to do that for the whole European Union, and that was why it could be negotiated through, I guess. And California was also one of the early examples on this type of policy. I will take the example from Denmark, where I think this is done in a very clear and very transparent way and easy to show here. First, you can see what the blue bar, all the existing buildings. Then you can see one of the old building codes, 1980, 1995, 2006. Those building codes every time took off some of the energy consumption in buildings, stepwise every 5 to 10 years. Then they made a decision in Parliament, which were adopted unanimous, and they have 7 parties in the Parliament, so it's a complicated to get all of them to vote for something, but they did for this. And they said, every 5 years, we take out 25% of the energy consumption in buildings. They have already implemented the 2010, and they have already found out that the 2015 won't even cost people money when they implement it. So by doing this, by warning people long time ahead, by using these building codes for good new buildings, you can drive the market the right way. And the government has decided we want plus energy buildings in Denmark, and it is in a near future, and that should be before 2030. They want a zero carbon society in 2050, so the buildings need to go there much before. If you compare to passive houses, then the next improvement in Denmark will make all buildings passive house standard like. And that's even a big hotel, a hospital, an airport terminal, and whatever you build, that will be in the passive house level in 5 years from now. They calculated the cost, and it might be big figures when you take that out as a number. How many millions would you invest, or billions would you invest? But if you compare to the price of the building, they find that the increase in building codes that they have shown, they take 3 to 6% extra costs from the first year. And no, fine, yes. And then with time, it drops even further. And when you go a few years out in the time, you can't even see the difference in the price when you try to estimate this. You have seen similar calculations in other countries showing that you can go very far without impeding costs. Eduardo already told about the European directive where all the members plus the associated countries, they have to follow this country. And many countries that want to be member of the European Union in the future, they are also trying to implement this kind of policies. And that should drive it close to zero energy. And Eduardo already told that it would take a little time for us to define how this is going to happen. We tried in IEA when we came to the conclusion that the countries were not implementing all our recommendations. We said that's not because they don't want it, that's because they don't know how to do it. We believe in the good in people and the good in countries. So therefore we tried to give them a guide on how to do this. And I have the real booklet here. We made what we call a policy pathway, trying to tell countries or systems, it could be a system like Resnet, could take the same lesson, how to develop and implement certification of buildings. We said we would do that in 5 phases, where you have one first called planning, then you have one called implementing, then you have one called monitoring, then you have one called evaluating. And we looked at the global scale, and we looked at different types of systems. And it's very funny, but nearly all of the systems, or many of the systems, they focused on the implementation part. And they didn't spend much time on the planning, and they didn't spend so much time on the monitoring, and most of them, they never spent any time on evaluation of the systems. It's such a big fight to get the laws through and all these implementation structures, so they never got energy for anything else. And it's quite stupid, because the planning part is ensuring that you do it in the right way and that you get a cost optimum in your system. And the evaluation afterwards shows you that it's working, what you do. And if the evaluation shows it's not working, you should go back, plan a revision of this, and then implement that, monitor it, and evaluate it again. It should be a natural circle to go around, so you end with a snail getting more and more clever. We found 10 critical steps, and we found a lot of lessons when we looked around, and we ended up with 38 recommendations for things you should do on the way to get a very good policy. A few key points is solve many questions very early in the process. If you want a different scheme, you should probably take a different path to get there. Communicate very openly at all stages. Don't keep this a secret. The hammer will come one day sooner or later when people find out what you implemented. It's better to get it early when you can still change. Involve all the main stakeholders all along the way. Consult them. They might have good ideas, but at least if you consult them, they can't come back and say this is a stupid system afterwards. They should have said it at an early stage. Plan training of assessors, that was also discussed. We heard it from the Green Building Councils, that if you don't have assessors, you might have a market, but you can't take it up, and you might be discredited in the future, because people say, yeah, but we can't get those consultants, or we get somebody who do a bad job. Leave time for the important processes, and combine this policy with other policies. If you don't have other policies, you get paper, as it was said in the CA presentation. I don't say more about it, but you can come back at 1:30 and you can hear a lot about this. And I have 3 copies, and I will give them away in that session. So that's one way of getting them. Then we have planned more policy pathways on. There was one which is already out on monitoring and verification of appliance certification or standards. We have one on the way on public-private partnerships and policies for advanced buildings, cool buildings in hot climates, trying to help developing countries in how to develop building codes and policies for buildings. We hope to have one on energy efficient windows, and we have industry, and we have things about solid state lighting on the way. The last thing I will mention, I hope I have a few minutes left, Stephen, is that we have also been tasked in IEA by the G8 countries in collaboration with the 5 major developing economies, China, India, Mexico, Brazil, and South Africa, and the European Union, to develop something called Sustainable Buildings Network. When we started looking, and I tried to make a list of all the networks which could be relevant for this, I made a list on 150 networks, international networks, and then I said, I can't make this list. So there are already so many networks out there. So the only way I saw forward was to try to make those networks work more together, and therefore I'm very happy to hear about the new strategic partnerships that you do here in US, making those actors work together and tell the same story to the policymakers. It came out of a dialogue process which were between all those 13 big countries and the European Union, and it's now a subtask to the International Partnership on Energy Efficiency Collaboration, which is also including those countries and some other countries too. The idea is again to mobilize existing stakeholders, existing networks in getting more clear messages, because if a policymaker is hearing what you should do in buildings, that's solar systems. Next day somebody say, no, it's just change all the windows and you're there. And then the insulation industry and say, those people are wrong, you should just insulate the buildings. And then the people come from technology and tell them it's smart metering, it's smart systems that you should install. What if all those 4 people came with the same message? You should do all of it at the same time. There is room for all of us, we have the same key message. Then you would probably start seeing the policymakers move. So this is one of the ideas. Another one is to make very easy communication. I work for ministers and in ministries, and messages there, they couldn't be longer than half a page, and the best messages were 5 lines long. If you write 3 pages, the minister would never read the 3 pages. He would ask somebody to make a very short summary of what you wrote. And that means somebody who knows nothing about what you're writing about is writing a short story, which is very difficult to write. So one of the ideas here was to say, why don't we, as a common work here, try to prepare 5-liners or 10-liners for people at a policy level. It's the same people working in DOE who wants to know about policies around the world. They don't go out there and read a 300-page report. They want fast messages because they have to deliver tomorrow, not in 3 weeks from now. So the idea is, again, condensing knowledge which is there, make it available for the policymakers. They can't search on the internet and find those big reports, and they don't know what to believe and what not to believe. If all the networks agree this is the message and it's 5 lines long, then you have an impact. I don't go in details with this. Again, you can come back and hear more about it later, but it is this getting the link between the technical stuff, all the good solutions which already exist, and then it is to, I don't know what you say here, but you share things between good and bad, and you want to show those people that some of those policies actually works. Most of the policies you hear about, it's the government itself that tell that we just implemented a policy and it's fantastic. And they never evaluated it or tried anything. So we would like to say, here you have a policy, you have a very good implementation, you have an evaluation by an independent institute. That is a policy which is worth copying. We will focus on some key areas from the start of this, which is building codes, zero energy buildings, deep renovation of existing buildings, and intelligent tropical architecture. That's where I think Florida could be very useful, because you have a lot of solutions which can be used out there. But the countries do themselves, because 200 years ago, nobody built a building that needed cooling because you couldn't install it. So you built a building that didn't need cooling, and then you still had a nice indoor climate. Why not try to dig up all the good solutions which already exist in India, in Mexico, and other places? This is the idea, but people are so spread out that they do not always talk together. I would say here in the end of the presentation that energy performance certification is a very strong tool to improve energy efficiency in buildings, and you all know that in connection to new buildings it can help you to ensure compliance. You can tell people, am I really getting the building I'm trying to buy, and is it really complying with the building code, or is it just something that somebody said and it's not really checked? It can definitely also support buildings that's much better than the building code. That's the only way you can get a stamp. An independent person said, this building is a HERS 60 or a HERS 40 or something like that, and therefore you know that this building performs better, also when I move into it and not just when it was on paper. In existing buildings, it can help to make it energy visible. Most people have no clue. We saw good examples on how this is becoming uptaken. It can show improvement in energy efficiency. It can show that you in an existing buildings really fulfills maybe today's standard, and that is a way to get that certified. It can document that you even passed that standard and maybe have a zero renovation project. Building performance is needed to help transforming the market into energy efficient buildings, and I talk more about this in my afternoon session. Just to conclude, because I said a lot of things and I hope there is a few of them that you would remember. The first one is that building the potential for energy efficiency is very big. We don't have to discuss more the number, how many percent or how big it is. It's extremely big, and let's start harvesting this potential. Using a holistic approach and passive savings are a cheaper way to get there than to do active systems. On longer terms, we should go for no energy buildings, at least very low energy buildings and maybe plus energy buildings. We need to transform the building industry, and that's a big impact. We have a lot of people that need to be trained, that need to learn a new lesson. Installers, architects, engineers, people in communities, and even people in banking. They need to know that they should pay more for getting an energy efficient building. Energy efficiency needs to become visible, and energy performance certification is definitely one of the big answers to this question. And I just presented the 25 recommendations, the policy pathways, the Sustainable Buildings Network, and some of all the analytic work we did, but I couldn't cover all of it.